Welcome to Brainwave Academy. Today I'm going to discuss about dimension in physics, and it's very easy. Before you do dimension, there are some things you're supposed to do. You have to know some formulas in physical quantities, and the first thing we should discuss today is distance, displacement, length, radius, all these ones are represented as L in dimension, and then mass is represented as M, and time is represented as T, capital letter T. This is what we need in a dimension. But before that, we have to know some physical, the formula for physical quantities. For example, speed. Speed is equal to distance over time. Distance over time. We have to know the formula before we can be able to actually know the dimension. And if I want to know the dimension now, what do I need to do? Distance is represented as L all over, and time is represented as what? T. That is L over T. And as you can see, this T is raised to the power of 1. This is written as L, then this T, if it raised up, this is positive 1, if it goes to change to minus 1. That is, the dimension for speed is LT minus 1. The other one is velocity. Velocity is equal to displacement all over time. And displacement is represented as L, and time is what? T. The same thing, we have LT minus 1, which means that the speed and velocity have the same dimension. The only difference here is that speed is a scalar quantity, while velocity is what? A vector quantity. But let me ask you a question. What is the similarities between the speed and what velocity? Sometimes wife used to ask this question. And what you need to say is that both speed and velocity are connected with time. They are both terms related to what? Motion. That is two similarities. But if you are talking about differences, the one is what? Scalar, while the other one is a what? Vector quantity. Let's move. This is number 1, this is number 2. Then number 3, when you have the acceleration. Acceleration is equal to velocity over time. And the dimension of velocity is already expressed LT minus 1. All over time is T, raised to power 1. T is common according to law of indices. When they have division sign, if it goes up to minus, LT is common. We have minus 1. If this one come up, we have minus 1, which means that we are going to have LT minus 2. Which dimension for acceleration is LT minus 2. Of course, acceleration is also what? Vector quantity. Therefore, we have force. Force is equal to mass times acceleration. Mass times acceleration. And the dimension for mass is already given as capital letter N. The acceleration, we already know it as LT minus 2. LT minus 2, which means dimension for acceleration force is what? MLT minus 2. Then the fifth one is let's say pressure. Pressure is equals to force all over area. And mind you, force is also what? Vector quantity. And the dimension for force is what? MLT minus 2. All over area is what? Length times breadth. Which length is L, breadth is also L. Please take note of that. Breadth is length is L, while what? Breadth is so what? Breadth is L, and what? Length is so what? L. We have this is raised to power 1, this is raised to power 1. We have N. Of course, this one is raised to power because L raised to power 1 is L. Raised to power 1, T raised to power minus 2. All over L. 1 times 1 is 1 plus 1 is 2, because the multiplication sign of what? Of indices, when you have multiplication between two alphabets, you add the power. So we now have N Then I'll pick n now. N is common, I'll pick the first power. This is 2. If it goes up, it changes to minus 2. 3 raised to the power minus 2. Which is equal to n. L minus 1 minus 2 is minus 1. Then 3 raised to the power minus 2. Mind you, the dimension for pressure is ml raised to the power minus 1, 3 raised to the power minus 2. And take note that the dimension for pressure is the same as dimension for Young modulus, and also the dimension for stress, tensile stress. Thank you and peace out.